Well, today I'm going to do a little bit of a tutorial on sound design, and it's not something we've really spent a lot of time on so far, but it's a really great way of doing it through the modular. So every single sound that you hear in the world is made up of component sine waves. So if we're going back to physics or science from high school, you might remember if you've ever seen a sine wave, it looks like that. It's like a curve. I'll show you one on an oscilloscope in a minute. And basically everything you hear can be broken down into different frequencies of these sine waves, and you can combine them together to make some really complicated sounds. So I'm going to show you how we do that. Okay, so here is our oscilloscope here, and I'm just going to turn this up a little bit so we can hear it. Okay, and I'm going to adjust the pitch on this. And you can see there that the shorter the waveform is, the higher it goes. So just as an analogy, women's voices tend to be higher than men's voices because of the length of the vocal cords. And so smaller things tend to be higher pitched than lower things. So this is why we're getting this change in pitch here. Now we can combine lots of these different sine waves together to make really complicated sounds. So that's what I'm going to show you now. Now I've combined two sine waves together. Now you'll hear them. I'll turn them up, and it's going to be a really annoying noise, but let's listen to it. And I'll adjust the pitch of those two relative to each other. You can see the size of those waveforms changing. They get longer as the notes get lower. Okay. So now what I'm going to do is run both of these signals through what's called a ring modulator, and it's going to take one signal, overlay it on the other, using it to modulate the underlying frequency. Sounds complicated, but let's look at it. So now from those two basic sound waves, we have a much more complicated looking wave, which sounds like this. You can hear it's got overtones. It's kind of a really metallic sound. It's a little bit more obvious if we trigger it. So now I'm triggering that, and you can hear it sounds very, very different than what we started with. This is actually foundation of things like robot sounds, a lot of bells, glass. All of those come from running through this little processor here. So we can adjust this and do lots of weird things to it if we want to. So that's a very basic intro to sound design using component waves to create something that's much more complicated. In future weeks, we're going to have a look at something called a vocoder, which is what's used for doing robot voices, but it really uses the same thing. You have one wave overlaid on another one, which is then kind of putting its character onto an underlying wave.